In this video, we will learn about the set. A mathematical set is a well-defined collection of objects. It is labeled using capital letters such that we can have a set A, a set B, and so on. This symbol is used to represent the element or member of a set. So an element of a set is simply a member of a set. Now we have to keep in mind that the elements of a set are enclosed in a pair of curly braces. So if you want to say that set A has the elements 1, 2, 3, 4, 5, we have to enclose this list of numbers in a pair of curly braces. Again, if we want to say that set B has the elements 5, 6, 7, we have to enclose the list of numbers in a pair of curly braces. This symbol is used to represent the subset of a set. A subset is a set. It is another set that is part of the given set. For example, the numbers 2, 3, 4. The set of the numbers 2, 3, 4 is a subset of the set A because 2, 3, 4 belong to the set A. The set of 7 is a subset of set B because 7 is part of the set B. Either of these two symbols is used to represent the null set. The null set is also known as the empty or void set, and that is because the null set is a set with no elements. One thing that we have to remember about the null set is that it is a subset of any set. Now this symbol is used to represent the universal set. The universal set is the totality of all elements or sets involved in the problem. We have what we call the cardinality of a set. The cardinality is simply the number of elements of a set. For example, let's say we have the set A with elements 1, 2, 3, 4, 5 and set B with elements 5, 6, 7. The cardinality n, or the number of elements of A, is equal to 5 because A again has 1, 2, 3, 4, 5 elements. Now the cardinality of B is 3 because set B has 1, 2, 3 elements. Now how do we get the number of subsets of a set? First, let's consider the types of subsets. The first type is the proper subset. The proper subset is part of the set that is not equal to the set. So a proper subset is a subset that is not equal to the set. So what are the possible proper subsets? First is the set of each element. Second, you have the set of each combination of two elements. Then we also have the set of each combination of 3 elements and so on up to the set of combination of n minus 1 elements. Then, since the null set is a subset of any set, remember? So the null set or empty set is another proper subset of a set. Now the second type of subset is the improper subset. And there is only one improper subset, that is the entire set, because the entire set is equal to the given set. Now this is the reason why the proper subsets stop at the set of combination of n minus 1 elements, because the combination of n elements is the entire set, and again the entire set is an improper subset. For example, let's say we are given a set B. It has the elements 5, 6, 7. Okay, the question is what are the subsets of B and how many are there? Okay, first, proper subset. For the proper subset, we have the set of each element. So we have the set of 5, the set of 6, each element, the set of 7. Then we can have the set of combination of 2 elements. Let's combine 2 of these 3 elements, so 5 and 6, 5, 6. 5 and 7, rather 6 and 7, 6, 7. And we can also combine 5 and 7, so we have 5, 7. Those are the possible combinations of 2 elements. How about the combination of 3 elements? So we have 1, 2, 3, 5, 6, 7. Notice that this is the given set, set B. Okay, so we have to add the null set. So how many elements are there? 1, 2. Rather, how many subsets does set B have? 1, 2, 3, 4, 5, 6, 7, 8. So set B has 8 subsets. Now, if we use the term subset, that refers to all the sets, meaning the combination of proper and improper subsets. Because notice here that we have the improper set or the entire set. Since finding the number of subsets gets challenging when the number of elements gets bigger, we can use a formula to find the number of subsets. So for the number of all subsets, we use this formula. X is equal to 2, the base 2, to the n exponent. What is the n again? That is the number of elements of the set. Now let's prove this equation or formula. Let's say we have a set A. It has the element 1. So the number of elements n is only 1. Okay, now what are the subsets of this set? We can have the set of 1, and that is already the given set. So we add the null set. Okay, so how many subsets? We have 2 subsets. Next, let's say we are given the set B. It has the elements 1, 2. Okay, what are the 1, 2. So there are 2 elements, and n is equal to 2. What are the subsets of this set? We have the set of each element, set of 1, set of 2, set of combination of 2 elements, 1, 2. And notice that that is already the given set, so we add the null set. So how many subsets do we have? 1, 2, 3, 4. So 4 subsets. Okay, next, let's say we have the set C. It has the elements 1, 2, and 3. Notice or recall from the previous slide. Okay, in the previous slide, we were given a set with 3 elements, so n is equal to 3. How many subsets did we get for the set? We have 8 subsets. So if the number of elements is 1, there are 2 subsets. So 2, of course, is 2 to the 1. If the number of elements is 2, there are 4 subsets. Of course, 4 is 2 squared, right? 2 to the 2. 2 times 2 is 4. If the number of elements is 3, there are 8 subsets. So, and yes, we know that 8 is 2 to the 3. 2 to the 3, or 2 times 2 times 2. Therefore, this equation is correct. Okay, but remember, yes, that 2 to the n gives you the number of all subsets. That is the number of proper subsets plus the improper subsets. So if you are asked to get the number of proper subsets only, you have to subtract 1 from 2 to the n, because in 2 to the n we have the improper subset, which is the entire set. Let's consider some problems on sets. First, how do you write a set E whose elements are the numbers from 3 to 7? So we use the capital letter E, okay, and we list the numbers from 3 to 7. Those are 3, 4, 5, 6, 7. For this to become a set, we have to enclose the list in a pair of curly braces. For the next 2 problems, let's say we are given a set A with the elements 3, 4, 5, 6. a set B with the elements 5, 6, 7, 8, 9, 10. Okay, next question is how many elements does set A have? The number of elements of A is 1, 2, 3, 4, 4. Okay, next, what is the cardinality of set B? Now remember that cardinality is simply the number of elements. So this question is the same as how many elements does set B have? So the cardinality or the number of elements of set B is, let's count them, 1, 2, 3, 4, 5, 6. 6. Okay, next question. How many subsets does set A with the elements 3, 4, 5, 6, 7 have? Okay, the question is the number of subsets. Again, when you have only this word subsets, that means the total number of subsets or the number of proper subsets plus the number of improper subsets. So the formula for that is 2 base 2 to the exponent n. Okay, so first question is how many elements does set A have? Let's count them. 1, 2, 3, 4, 5. Okay, therefore the formula is 2 to the 5. Okay, so 2 to the 5 is 5 2's multiplied together. So we have 2 times 2 times 2 times 2 times 2 is equal to 32. Therefore, set A has 32 subsets. Okay. Next question, if a set has 4 elements, how many proper subsets does it have? Okay, so take note that the question asks for the number of proper subsets only. Okay, 4 elements, so n is equal to 4. The formula again for the proper subsets is 2 to the n minus 1 to account for the, or rather to discard the entire set or the improper subsets. Okay, so 2 to the n, 2 to the 4 minus 1. 2 to the 4 is 4 2's multiplied together. So we have 2 times 2 times 2 times 2 and minus 1. 2 to the 4 is 16 minus 1, 15. Therefore, the set has 15 proper subsets. If you have any question, please leave a comment.